Good afternoon, everyone. I would like to welcome you all for the third day FDP on 6 days FDP GAN-based hybrid deep learning approach of IoT organized by the Department of Computer Science Engineering, Vinayaka Misha, Kripananda Virya Engineering College in association with Pencilbits. I take this immense pleasure to welcome our today's speaker, Ms. M. Venkatalakshmi ma'am is an accomplished assistant professor in Department of Computer Science Engineering at Anna Acharya Institute of Technology and Science, AITS Tirupati, with the overall 12 years of teaching experience across the various institutions. She has developed her strong foundations in computer science education. Mr. Venkatalakshmi ma'am has hold M.Tech degree in computer science and engineering from JNTU Anandapura, Andhra Pradesh. She has made significant contribution to the field of through numerous publications in estimating the national and international journal, including those indexed in the Web of Science and Springer. She has actively participated in the various workshops and faculty development program and highlighting her commitments to the continuous professional development and stay tuning with the current of industrial trends. Her research interested accomplished with a wide array of topics, including the machine learning, deep learning, artificial intelligence, data science, computer architecture, operating system, Python programming, data structure, C programming, computer engineering, and also designing and the, analyzing of algorithms. As a life member of Indian Society of Technical Education (ISTE), she is dedicatedly enamored to the quality of technical educations in India. Additionally, she is pursuing her PhD at MBU in Tirupati, focusing on innovation approach of area of expertise. Mr. Venkatalakshmi ma'am has also served as a resource person for the various programming languages, including the C, Python, and deep learning, further demonstrating his dedications to the education and empowering his next generations to the computer scientist. Welcome you, ma'am. Welcome you, ma'am. It is audible, ma'am.
Yes, ma'am. Audible, ma'am. Good afternoon,
Good
ma'am.
afternoon, ma'am.
Shall I start, ma'am?
Yes, ma'am. Good afternoon, ma'am. You can start, ma'am.
Okay, ma'am. My screen is visible, ma'am?
Yes, ma'am.
Okay, ma'am. So very happy noon to all the participants. As part of the third day, I will continue with a GAN-based hybrid deep learning approach for IoT. So previous classes, in day one, Dr. Shashikumar sir is giving the information about sensors of the how data collection will be used and what are the different techniques used in data collection with the help of IoT. So there are classifying machine learning and deep learning algorithms. And day two, Dr. Madhumita Madam is giving the concepts of deep learning techniques. And now I will discuss what is the title, a GAN-based hybrid deep learning approach for IoT. What will happen? Ma'am? Madam? Hello? Madam?
Ma'am, it is audible, ma'am.
Yes, audible, ma'am. I will share my PPTs. You have to present in your system, ma'am.
No, I don't have system, ma'am.
Madam, it is audible and also visible, ma'am.
Visible, sir, but it is not scroll, sir. I mean, it is not going for another slide. That's why, sir.
ನಮ್ಮ ಕಾಲೇಜ್ ನಡೆದು Venkatlakshmi madam, any problem, ma'am? I am Rajanaran from Vinayagar Missions.
Sir, ma'am could not able to present her PPT. So, can hold on over 5 minutes, let her sort out the problem, sir.
Okay.
Hi, good afternoon.
Now my screen is visible, ma'am?
Yeah, it's visible.
Yes, sir. Okay, sir. I'll continue, sir.
Yeah, ma'am.
So these are the contents about today's session. First one is GAN. We are giving the information about GAN and what are the different types of components used in GAN and what are the types of GANs, what is the architecture of GAN and what are the applications of GAN, advantages, disadvantages of GAN, and other techniques are deep learning key concepts, advantages, disadvantages, and we'll discuss hybrid deep learning, advantages of hybrid deep learning, IoT, and what are the different types of security issues used in the GAN with the help of IoT. So these are the contents, and I'll start with the about GAN. So GAN is generative adversarial network. So it is the one of the important popular deep learning technique. It is mainly used in the machine learning and deep learning. So GAN is uses two neural networks. So with the help of two neural networks, it is captures, copying, analyzing the variations on the data set. So with the help of two neural networks, so it is define the structures in two different ways. So one is the generator and another one is the discriminator. So these generative adversarial network consist of three words. Those three words are generative, adversarial, and networks. So generative means it is generate the new things, generate the new models, how data is generated, like that. And adversarial means it is gives the advice. So use generate new models and depends on the other different data sets, training data sets. So it is depends on the, it is gives the advice. Next to networks. So these networks are neural networks. It is trains the models, and these networks are very important. And next one is the understanding the basics of GAN. So these generative adversarial networks are a part of the machine learning models. This is introduced by Goodfellow in 2014. So it is GAN is creating realistic synthetic data by leveraging an adversarial framework. So these GANs are recognized by the ability to develop with high quality images, videos, and real world mimic samples. So this GAN is uses the unsupervised learning model. In unsupervised model learning, it is uses two different types of neural networks. They are trained to compete each other. So these are very popular nowadays. We are using these GAN techniques. So recently, GANs have useful for data augmentation, reinforcement learning, and semi-supervised learning techniques. Next, architecture of GAN. So this architecture uses real data samples, generator, discriminator, condition, is it correct? Okay, for example, this latent random variable is a database. From this database, the generator takes some data as randomly. So that data is, this generator is gives the output. That means it is generator is creates fake samples of data. That fake samples of data is sent to the discriminator, and this discriminator is also having another input, that is real data samples. So it is takes both the generator output and real data samples. So from that, the discriminator is finding another output, that is, if the data is real or fake. So this is the architecture of generative adversarial networks. And we'll go for another one. Components of GAN adversarial GANs. So this is the generator and discriminator. So the training data set means a real data set. The real data set is directly giving the input to the discriminator, and generator is also creates a fake images, that output also giving input to the discriminator. Finally, the discriminator is finds whether the given data, I mean, it is collects the data as input from the generator and training data set. From that, it is finds which data is real and which data is fake. Next, where discriminator means, so in this discriminator, so it is a classifier that identifies real data from the fake data that is created by the generator. The discriminator is a classifier. It acts as a classifier. It is identifies data from the fake data. Real data is identified from the fake data. That fake data is provided by the generator. And generator means, so it is generator is creates fake data from the feedback of the discriminator. It is incorporating the feedback of the discriminator. Next, generator training. So in generator training, latent space means it is takes the data from the database. So the database is sometimes it is noisy data. So from that, the generator is creates fake samples, and the discriminator is takes the input as random sample, real samples. So it is generates real images. So generator is takes the noisy data in the from the database, and it is creates fake samples. Discriminator is takes real data samples and it is generates real output. So that is in a generator training. Coming to the discriminator training. In discriminator training, so the generator is takes the database data from the database with a noisy, and it is generates fake samples. So that fake samples is sent to the discriminator. From that, it is creates fake data only. So this is the difference from the generator training and discriminator training. In generator training, so they are different. Generator is takes data and creates fake samples, and discriminator is takes real samples and generates output as a real. Whereas in discriminator, it takes the generator output, that is the fake samples, that is the input of the discriminator. And whenever we have to give the fake samples to the discriminator, it is also gives the output as fake. Next one is types of GANs. So there are different types of GANs is there. So from that, we have to first discuss the DC GAN. This DC GAN is the deep convolutional GAN technique. So it is one of the most used and powerful, successful types of GAN architecture. And it is also implemented with convenates in the multi-layer perceptron. So in this diagram, it is takes the random input to the generator. So it is creates the output as a sample. That sample data means a fake data. That fake data is given to the discriminator. The discriminator, if I am giving the fake data to the discriminator, it is output will be generator loss. So here we are using the back propagation technique. With the help of back propagation technique, it is takes the real images, and if we are taking the real images, those are the real samples. Those real samples are giving to the discriminator. So when the output will be discriminator loss. So this is the main technique in deep convolutional GAN techniques. So it is provides high quality images with the help of convolutions. Next type is conditional GAN. That means it is a C-GANs. C-GANs are extra label information to generator for getting the better results. So C-GAN can be described as a deep learning method in which some conditional parameters we are giving the input to place. So here additional parameter Y is added to the generator and getting the corresponding data. Labels are also put into the input to the discriminator, order of the discriminator, to help distinguish the real data from the fake generated data. So here it is a desired response. That means it is a random noise. That random noise is applied to the generator. This generator generates data. So after generating, it is sends the data to discriminator. Discriminator is finds whether the data is real data or generate data. That means fake data. So if we are giving the real data to the discriminator, it gives real data. If you are giving the fake data to the discriminator, it gives generate data. That is conditional GAN. Next one is vanilla GAN. In vanilla GAN, it is a type of generative adversarial network. So it is uses the generator and discriminator with the help of multi-layer perceptrons. So the vanilla GAN is the algorithm is really simple. It tries to optimize mathematical equation using stochastic gradient descent. With the help of this algorithm, we have to implement this vanilla GAN. So it is a database with low dimensional latent space. So this data is giving to the generative network G, and this generative network is to generate the fake images. These images are giving to the discrimination network. So when this discriminative network gives fake data. So it is a high dimensional sample space. That means real data. From that real data, we have to give real images. These images are giving input to the discriminative network. So it is gives real data. That means it is data as real or fake. So it is vanilla GAN. And the next one is the super resolution GAN. So it is same in the name itself, super resolution GAN. It suggests a way of designing GAN which the deep learning network, so along with the adversarial network, in order to produce high resolution images. So this is gives the high resolution images, and it is also generates 3D images with real and fake. So this type of GAN is particularly used in optimally upscaling native low resolution images. So it takes the low resolution images, and it provides the output as super resolution, high resolution images with less errors. Next, working of GAN. So the working of GAN, it can be summarized in the below steps. So first, the generator takes a random number and generate an image. First of all, it takes the random number from the database, and it generates the image. So after generating the image, it gives the input to the discriminator. and the authenticate images are taken from the actual data set. So we have to take the data set from the database. So from that, we have to give the input to the discriminator. The discriminator contains both real data and fake data. I mean, real images and fake images. So from that, it is predicts. The discriminator is predicts which are real images and which are fake images. It is differentiate. So as an input, as an output, it returns probabilities of a numbers between 0 and 1. So it is gives the input in two ways, that is either 0 or 1. So 0 means it represents the prediction of fake and 1 represents the authenticity. I mean, it is a real image. So these are the few steps of working of GAN. So see the diagram. So this diagram is previously discussed again. So in the following given steps, we have to again define this one. So this is the d-dimensional noisy vector. So from this noisy vector, it is takes the data by the generator network. This generator network is creates fake images. So these fake images forwarded to the discriminator network, and the discriminator network also collects the data from the real images. So now this discriminator is predict the labels, which one is a real image, which one is fake image. It is identifies. This is the fully working architecture of GAN. Next, applications of GANs. So these GANs are used nowadays in many areas, such as first one is the image synthesis and generation. So in image synthesis and generation, we have to take the pictures and synthesize with the new way. I mean, we are generate new model from that image. So they may create fresh lifelike pictures that mimic training data by learning the distribution that explains the data set. So actually it is takes the data from the data sets, like they are taking any images as a real images that can be in the same way we have to create as a another image. So that created image which will be seeing as a real image or a realistic image. So it is looking like that. So the type of image synthesis generating with the help of GAN. Next, image to image translation. So here the GANs or transfers. I mean, it is takes one image. So from that image, it is translate another image. First one is the black color image, and the same way we have to convert that into black and white. Or first of all, we have to take horses. So that is original image. So from that horses, we have to generate new image as donkeys. That is image to image translation. Next, text to image synthesis. Text to image synthesis means first we have to give text. So from based on the text, the image will be creates. So for example, a bird has yellow body, and the peak is very short peak. So that is the text information that can be converted with the image. Same body is in yellow color, and peak of that bird is very short. So in this way, whatever the data we will give, so in the same manner, in the same way, I mean, it is takes the input and creates an image. Next, data augmentation. In the data augmentation, it is presents the data and increase the robustness and generalizability of machine learning models by creating synthetic data samples. Okay, so here we have to take the data and that data can be improved the robustness and generalizability. So these can be used with the help of machine learning models. So with the help of these machine learning models, it is creates the realistic data from the original data. Next to data generation for training. So the GANs can enhance the resolution and quality of low resolution images. So it is takes the high resolution images and it is creates low resolution images. So high resolution images, it takes the low resolution images, it is generates high resolution images. It is takes the high resolution images and it is generates the low resolution images. So vice versa, it is generates the data. Next, advantages of GAN. So in the coming to the advantages of GAN, it is uses synthetic data generation. That means from the original data, it is creates the realistic image. From the original image, it is creates the realistic image. Apply the data augmentation and anomaly detection or creative applications. Next, high quality results. It is provides high quality results and photorealistic results in image synthesis, video synthesis, music synthesis, and other tasks. So these whatever they generates like photos, videos, or any other music, this can be with high quality results. Next one is unsupervised learning. So the unsupervised learning, the GANs can trained without labeled data. Unsupervised means in machine learning or in deep learning, it is takes the unlabeled data, making them suitable for unsupervised learning tasks where labeled data is sacrificed, scarce or difficult to obtain. So only the GAN advantages, it is generates only labeled data. Without labeled data, it is identifies it is unsupervised learning or it is a fake data or it is real data. It is very difficult task. Next to versatility. So GANs can be applied to wide range of tasks like including image synthesis, text to image synthesis, image to image translation, and anomaly detection, data augmentation, and others. So these are applies a wide range. Next one, disadvantages of GAN. So it is takes the training instability. So actually you have to take the training data set, but coming to the disadvantages, the training is instability. It is the training data set will be, GANs can be difficult to train with the risk of instability more, collapse, or failure to converge. So for example, instability data or any collapsed data or failure. So this is very difficult to train the such type of data sets. Next, computational cost. So it is contains computational resources and can be slow to train. So with the help of some resources, it is the training of the data set will be very slow, and especially for high resolution images or large data sets. So for these, the computational resources are working as very slow. Next to overfitting. Overfitting means can train the data. It is producing synthetic data that is too similar to the training data and lacking diversity. So whatever the data we have to produce for the realistic original image or realistic data, So that the data is similar to the training data. It is produces synthetic data that is similar to the training data. So first of all, we have to take the data from the original database or data set. So from that, we have to create the fake image. So that image is similar to the training data. So that is also one of the disadvantage of GAN. Next, bias and fairness. The GANs can be reflect the biases and unfairness present in the training data, leading to the discriminatory or biased synthetic data. So here, the GANs or biases or unfairness. It is reflect the data on the GANs as unfairness. So this unfairness is present in the training data set. That means it is fake images. So fake images are in the training data set. It is generates fake data. That means it is looking like a realistic image. Next, interpretability and accountability. So the GANs can be opaque and difficult to interpret or explain, making it challenging to ensure accountability, transparency, and or a fairness in their applications. So this is also one of the disadvantage. It is not interpret with the other uh, accountability, transparency, and fairness. Such type of applications, it is showing unfairness. Next, challenges and limitations of GANs. So first one, mode collapse. Mode collapse means, so it is one of the most challenging GAN, that is a mode collapse. So this mode collapse is occurs when generator produce a limited range of outputs. That means it is generates a limited number of fake images. That is the output. So that is essentially fooling the discriminator with repetitive patterns. So whatever the fake images is generated by the generator, that is stored in the fooling. So in the that is placed in the discriminator. So while the GAN might appear to be performing well, the diversity of the generated data suffers significantly. So whatever the data that is created by the generator, that data is stores in the fooling. That fooling is presented in the discriminator. So this is uh, generated. So when that time of the diversity is suffers, the data will be suffers. For instance, the image generation task, the GAN might consistently create image of one category while neglecting the others. For example, we have to create one baby image. So background of that baby image, and it is similar to the baby image. So that can be looking like as a synthetic image. So we have to find which one is the realistic image and which one is the fake image. We are not finding that as, and this GAN is uses variety of limitations when requiring the diverse outputs, such as creating data sets for robust in machine learning models. So in machine learning models, mainly the mode collapse is uses. So this mode collapse is used in the machine learning models and also in deep learning models. Next to training instability. So this is also disadvantage and resource intensive requirements. So these requirements are significant computational resources. These are uses the high performance GPUs or TPUs. So these are the handling of these GPU or TPU is very complex. I mean, it is contains different types of operations. Those operations are very complex, and it is uses massive data sets to require the effective training. So, moreover, the training often involves multiple iterations to fine tune the results. It is consuming considerable time and energy. So this is applies to the small organizations or uses by the researchers with a limited access to advanced hardware. This becomes a substantial barrier to entry. The resource intensive nature of GANs also raises concerns about energy efficiency and environmental impact, particularly as models grow more complex in resource intensive requirements. Next one is deep learning. So this deep learning is a branch of the machine learning. See this diagram. Deep learning is the subset of machine learning. Machine learning is subset of artificial intelligence, and data science is also subset of artificial intelligence. So the neural networks are used in the deep learning techniques. Neural networks means neurons. So since neural networks imitate the human brain, it is, I mean, these neural networks are looking like the human brain. And so deep learning will do. In deep learning, nothing is programmed explicitly. Basically, it is a machine learning class that makes use of numerous nonlinear process units. This performs the feature extraction as well as transformation. The deep learning models are capable to enough focus on the accurate features. It is predict the accurate features from the programmer and very helpful to solving out the problem dimensionality. Deep learning algorithms are used to especially when we have to use number of inputs and outputs. The deep learning is a subset of machine learning that focuses on the algorithms. These are inspired by the structure and functions of the brain. So, known as artificial neural networks. It uses multi-layer neural networks to model complex patterns and representations in the large data sets. Deep learning has a significant success. Deep learning is achieved a significant success in various domains like computer vision, natural language processing, and speech recognition. Next, there are very important key concepts used in the deep learning. So these are very important concepts. So first of all, the evaluation of machine learning to deep learning. So how it will be happen, the evaluation from the machine learning to deep learning. So before that, we have to discuss the evaluation of machine learning to deep learning. So what is machine learning? How deep learning is different from the traditional machine language? We will see. The machine learning is a subset of artificial intelligence, that is AI. It enables computers to learn from data and make decisions without explicit programming. That means we are not specially write the programs for taking the decisions. So it encompasses various techniques and algorithms that allow systems to recognize different types of patterns and from that it is makes the different predictions, and used on that it is improves the performance over time. So that is about the machine learning. Next, how deep learning differs from traditional machine learning. So while machine learning has been transformative, deep learning advances it is further by automating many tasks that typically requires human expertise. Deep learning is essentially a specialized subset of machine learning that is characterized by its use of neural networks with 3 or more layers. These networks attempt to simulate the human brains. That means neural networks are looking like a human brain. From that we have to learn a large amounts of data sets. And next one is the neural networks. So these neural networks are the foundations of deep learning. They consist of layers of interconnected nodes. Those nodes are called neurons. These are processed and transform the input data into the output. With the help of these neurons, we have to transfer the data from input to output. So it is containing different layers. What is the input layer, hidden layer, and output layer? Input layer takes or receives the input. The hidden layer is the intermediate layer to the input layer and the output layer. It is process the data. That means the hidden layer is process the data and learn complex features or patterns. So in deep learning, these layers can be many. Hence, it is called it as deep. Next one is the output layer. In the output layer, it is produced the final result. Example, classification or predicted value. So these are a few examples. So this is the information about in output layer. Next one is the training deep neural networks. How to train the deep neural networks? To training a deep learning models, it is involves the feeding data through the network and adjusting the weights or parameters of the network based on the error of the output compared to the expected result. This process uses algorithms like back propagation and gradient descent, stochastic descent algorithms it is uses. So with these are reduce the errors. Next one, activation function. So this is very important. So this activation function uses the each neuron. So for this, each neuron applies an activation function that determines its output. Common activation functions include, see here, tanh, ReLU, sigmoid, softmax. So these are a few activation functions. So here, ReLU means it is a rectified linear unit. Linear unit. It is used in the hidden layer for its efficiency, and sigmoid activation function. It is used for binary classification tasks, and softmax. It is used the output layer for multi-class classification problems. So these are all used in the hidden layers. Next, loss function. So with the help of this loss function, we have to measure the loss function measures the difference between the actual and predicted value. That means original image and fake image. So with the help of track model performance. So commonly the loss functions are binary cross entropy, categorical hedge, mean squared error, Huber, sparse categorical cross entropy. So these are the few common loss functions. So next one, back propagation. Back propagation is adjust the weights. First of all, it is follows from forward to backward direction. So whenever we have to apply the whatever the results we are not getting the predicted output. So at the time we have to apply the back propagation method. This back propagation method is adjust the weights of the in the neural network. Why? Because it is improve the performance and minimizing the loss function or errors. That's why we are using the back propagation. Next one is the stochastic gradient descent. This gradient descent optimizes the loss function. It is optimizes the loss function by adjusting the weights to achieve minimal loss. So we have to get the minimum loss at the time with the help of this stochastic gradient descent applies. So we'll get minimal loss. This stochastic gradient descent speed ups this process by dividing data into batches. So this stochastic gradient descent is divides whatever the data into the batches. So for that it is applies the loss function and find the less error prone data. So this is the formula for the stochastic gradient descent. W is equal to W minus JW. In stochastic gradient descent, samples are divided into batches. So instead of using the entire data set to optimize gradient descent, this is useful if you want to achieve minimum loss faster and optimize computational power. So we'll get the minimal loss. We have to apply the stochastic gradient data set descent on the data set. The data set is, first of all, we have to divide it into some batches. So after that, we have to apply this stochastic gradient descent. So from that, we'll get the minimum loss. Next one is the hyperparameters. So hyperparameters are adjustable parameters. So these parameters are very important in machine learning and deep learning, in artificial intelligence also. So these are mainly used in the deep learning. So those some important factors is there. So the hyperparameters includes learning rate, batch size, number of epochs. So from any data set or from any batches, we have to apply these hyperparameters on the data set. So learning rate means it is determines the step size of each iteration. So for example, we have to take we are having minimum 5 batches. From that minimum 5 batches, we have to take the batch 1. So we have to process that batch 1. So at the time, it is takes the step size. I mean, in batch 1, how many data sets is there, and which one, each one is containing how much step size. That means what is the size of that batch. So like that, it is applies and executes. So for executing batch 1, it is how much time it will requires. That is learning rate. And batch size, it is uses the number of samples processed at a time. In a batch, it is uses how many number of samples can be processed. That is batch size. Number of epochs. Epochs means iterations. How many number of iterations we have to process for each and every batch in that 8 samples. Or we have to apply the epochs for the entire data set, overfitting and underfitting on the basis of overfitting and underfitting. Next one is training deep learning models. So these training deep learning models, we have to require significant computations, power, and large amounts of labeled data to perform well. The training is involves data pre-processing, model selection, and hyperparameter tuning. This is about the training deep learning models. The training deep learning models uses data pre-processing. Data pre-processing means normalizing and transforming data to be fed into the model. So normalized data and without the noisy data, that data is giving to the or fed to the model. That is data pre-processing. And model selection. Model selection means choosing an appropriate architecture like CNN for image tasks or RNN for sequential tasks, or using multi-layer perceptron. So like that it is uses the model selection, and different models or different architectures is there. Next, hyperparameter tuning. So actually hyperparameters means it is adjustable parameters. Why? Because these parameters are used to improve the model performance. Coming to the hyperparameter tuning, it is adjusting the parameters like learning rate, batch size, and number of epochs to improve the performance. Whatever things we are discussed in the learning rate hyperparameters, the same can be executed in the hyperparameter tuning, because it is improves the performance. Next, why we are using this deep learning, why it is important. So the deep learning has become industry standard for several reasons. That is handling unstructured data. So deep learning models can learn from unstructured data and reducing the time to resources, real time and resources needed to standardize data sets. So this is because of this reason also we have to use deep learning models. So why? Because unstructured data also, from that data also we have to define the learn the models because of reducing the time. Next, to handling large data. So for this reason also we have to use the deep learning. I mean, it is very important. So with the help, with the introduction of graphics processing unit GPUs, and deep learning models can process vast amount of data at high speed. So for such reason also we have to use the deep learning model. GPUs are introduced with the high speed data. It is takes the vast amount of data with high speed. That's why also we are using the deep learning. Next, high accuracy. So with using the computer vision, natural language processing, and audio processing, so it is generates the accurate results. The deep learning model is provides accurate results. So for this reason also we have to use the deep learning. Next, to pattern recognition. So the deep learning is uses different patterns. Those are automatically detecting with the help of intervention of machine learning and deep learning models. So automatically we have present days, automatically we have to learn the detect the various patterns. It is related to machine learning and deep learning models. We have to identify as easily. So for this reason also we have to use the deep learning models. Next, types of neural networks. So only few neural networks I am introducing here. So deep learning models are able to automatically uses different types of neural networks, that is feed forward neural network, convolutional neural network, and recurrent neural network. Feed forward network is the simplest type of artificial neural network with a linear flow of information through the network. So it is follows as a linear fashion. The flow of information is flows from sequentially So these feed-forward neural networks have been widely used for tasks such as image classification, speech recognition, and natural processing. So these are the examples. In these places, we have to apply the feed-forward neural network, that is FNN. In image classification, speech recognition, and natural language processing, we have to use the feed-forward neural networks. And next one is the convolutional neural network. This convolutional neural network are specially for, this is used for specially images and video recognition tasks. So in this CNN, it is takes the data, whatever the data or image, that can be divided into different types of convolutions, and so those can be applied for activation functions. So from that we have to get the output. So CNNs are able to automatically learn features from the images, which makes them well suited for tasks such as image classification, object detection, image segmentation. So in these places, like image classifications, object detection, image segmentation. So in these places, we have to use the convolutional neural networks. And last one is the recurrent neural networks. So it is the type of neural network. It is process the data sequentially with the help of it is takes the time series and natural language. So these RNN are able to maintain internal state for capturing the information about the previous inputs, which makes them well suited for the tasks such as speech recognition, natural language processing, and language translation. So feed-forward networks takes the only data in the image classification, speech recognition, and the natural language processing. The convolutional neural networks is also used in the image classification, object detection, image segmentation, and this RNN, recurrent neural networks, uses the speech recognition, natural language processing, and language translation. That means we have to translate one language to another language. Next, deep learning applications. So nowadays we are using many number of deep learning applications such as self-driving cars, voice controlled assistants, automatic image caption generation, automatic machine translation. So these are the few examples. So self-driving cars means without a driver we have to give the instruction to that car, and so that is follows the instructions and to drive the individually. I mean, without a human interaction, without a human instruction. So it is a self-driving cars. It is takes the huge amount of data, captures the images, and process the huge amount of data. It is incorporated to take the left direction or right direction, or it should be stopped. So accordingly, it will decide what actions it should take, which will further reduce the accidents that happen every year. Next, voice controlled assistants. So mainly we are using Siri. So with the help of this Siri, I mean, we have to give the voice controlled assistants with the help of Siri. So it is comes the one thing that comes into our mind. So you can tell Siri whatever you want to do it for you. So and it will search it for you and display it for you. So it is searches the whatever you want and it is displays whatever you want. That is a self control voice controlled assistance. So example for this is Siri. Next to automatic Ma'am, now am I audible, ma'am?
Yes, ma'am.
Yes, ma'am, it is audible, ma'am.
When it is disconnected, ma'am.
10 minutes before, ma'am.
Okay, ma'am. So next, deep learning models. So these are different types of deep learning models. So one of them is a supervised learning model. This supervised learning model takes the labeled data set. So from that labeled data set, it is apply the training. So from this training, it is predicts the output. So this data supervised learning is consisting classification and regression problems. These are divided in supervised learning is divided into classification and regression problems. So classification means so the algorithm is divided data set into the categories based on the feature extractions. So this classification is purely based on the feature extraction. So example, ResNet 50 for image classification and BERT for text classification. So ResNet 50 means it is uses the 50 layers for the image classification and BET. This is a BET for the text classification. These are the popular models for extracting the images. Next to regression models, these models learn the relationship between the input and output variables to predict the outcomes. So it is depends on the input and output. I mean, it is maintains a relationship between input and output. So why? Because it is predicts the output. That's why it is depends on the input. The regression models are used for predictive analysis like weather forecasting, stock market performance. These are the popular models, and with the help of these, it is uses the LSTM and RNN. LSTM means long short-term memory, and RNN means recurrent neural networks. These algorithms, these models are very popular for weather finding the predictive analysis, weather forecasting, and stock market performance. Next, unsupervised learning model. This unsupervised learning model uses the unlabeled data. So these unlabeled data is formed into a cluster. So the unsupervised learning algorithm identifies the patterns. Means it is one type of pattern. It is one type of pattern, and it is one type of pattern. So these are also called as clusters. So these are unlabeled data. So this is the supervised learning data. This is a labeled data. It is in the line, and it is a same type of data we are using in the labeled format. So these models learn hidden patterns without human intervention, and these are used in the medical images, recommendations for engines, market research. So this is entirely, that means the unsupervised learning uses the cluster, different types of cluster. This is cluster 1, cluster 2, cluster 3. So like that, it is divided into different clusters. These are not labeled data or unlabeled data. Next, third one is the reinforcement learning. So reinforcement learning uses it is one of the machine learning algorithm. So our agent learns the behaviors from the environment. The agent takes actions and receive rewards, learning to achieve goals through the trial error without human intervention. And reinforcement learning is used in automation, robotics, self-driving cars, gaming, and space exploitation. So the reinforcement learning is purely based on the agent. So this agent depends on the environment, whether the environment is cool or rainy or a summer season, like that. And if he gets the actions, he takes either rewards if is that action is good or completed in time, it is gets reward. Next, so after it is applies, the agent is applies uh, training on the data without human intervention, and finally the agent is uses the deployment. So this deployment is a final result, that is either this deployment uses in automations, robotics, self-driving cars, gaming, space exploration. So these are a few examples for the reinforcement learning. Next, GANs, generative adversarial networks. So these GANs involves two neural network, that is generator and discriminator. These are produces the synthetic images in the instance of the original data. So these GANs are very popular for generating synthetic art, video, music, and texts. Next, graph neural network, GNN. So this GNN operates on a graph and applies in the large data set analysis and recommended for the different types of systems as a computer vision. So these are used for node classification, link prediction, and clustering. So see the diagram. This is the general design pipeline for a GAN model. So this is the input. In this input, you will have to give the input as finding graph structure, specify graph type, and scale. So this 1, 2 are giving as input, and 3 is the design loss function. In the loss function, we have to apply the training set. I mean, we have to set the training set. That training set is contains supervised model, semi-supervised model, and unsupervised model. And we have to apply different tasks, that is the node level, edge level, graph level. So from this, we have to get the output. This is the built model using computational modules. With the help of these design loss functions, we have to generate the output, the node embedding, edge embedding, graph embedding. So these are the different GAN layers. With the help of these GAN layers, we have to generate the output. So see here, skip connection, sampling operator, convolutional recurrent operator, pooling operator. So these, whatever the input we have to give, that input is a skip connection or directly go to the pooling operator. Otherwise, it is takes the sample operator and convolutional recurrent operator. So that is also forwarded to the pooling operator. With the help of this pooling operator, it is gives the information to the GAN layer. This GAN layer is finally generates loss function parameters. Next one is, next deep learning model is natural language processing. This natural language processing is uses different types of languages. It can be translated from one language to another language. So see here, language sparse, it is translates, autocorrect. These are different natural language processings. Natural language sparse, automatic text summarization, it is summarization, reporting, marketing, clinical, and chatbot is conversational AI, virtual agent, semantic and sentiment analysis is a positive. Language model is parts of speech, optical character recognition. So these are the different natural language processing techniques. So these are used for translating from one language to another language, autocorrect the words, and summarization of the text, reporting the marketing and clinical values, and you apply the conversational AI, a virtual agent for the chatbot, and positive or negative values is applied for the sentiment analysis, and the different language models are parts of speech. Nowadays, it is a optical character or recognition. So this is natural language processing. And next, convolutional neural network. So some popular deep learning algorithms is there, that is convolutional neural network, recurrent neural network, and LSTM, long short-term memory. So these are the popular deep learning algorithms. So coming to the convolutional neural networks, it is takes the input, hidden layer 3, hidden layer 2, hidden layer 1, and it is the input. From input to output, we have to process with the help of hidden layer. This hidden layer uses activation functions, loss functions. Yes, so these are the inputs. This input is applies to the first hidden layer, to the second hidden layer, from to the third hidden layer, and finally we'll get output. So in this way, we have to apply the convolutional neural networks. So here the CNNs acts as a feed-forward network for the image classification, recognizing the patterns, lines, shapes. So these consist of different types of different convolutional layers, pooling layers, and fully connected layers. So final output is the fully connected layers. These are all pooling layers. So it is a convolutional layer. So these are the pooling layers, and finally you'll get the fully connected layer. Next one is the recurrent neural networks. These recurrent neural networks uses the input, output, hidden layer, input, output, hidden layer, input, output, hidden layer, input, output, hidden layer, input, output, hidden layer. So these are different types of different recurrent neural networks. We have to unfold the data with the different weights. We have to calculate the output. So designed for sequential data where the output of one layer is fed back into the output. So the output of this layer is input to the another layer. The output of this layer is input of this last layer. This makes them suitable tasks for text prediction, stock price forecasting, and AI chatbots. So this is mainly used in these text prediction, stock price forecasting, and AI chatbots. And next one is the long short-term memory networks. So these long short-term memory networks uses the TANH function. I mean, it is a different activation function, sigmoid function. So this is uses different layers, input layer, hidden layer, and output layer. So the LSTMs are advanced RNNs that retain more information over time, solving issues like the vanishing, gradient descent problems. They consist of 4 interactive layers for processing long sequences of data. So those are layer, component wise, copy, concatenate. So these are the few components used in the LSTM. Next, we'll discuss about hybrid deep learning. So this hybrid deep learning refers to the combination of multiple deep learning techniques or models to leverage the strengths of each. The main goal of this hybrid deep learning is to improve the performance, accuracy, and efficiency of complex tasks. So by integrating different architectures, data processing strategies, or learning paradigms we are used in the hybrid deep learning approaches. So these are address the broader range of problems that may be difficult for single model or technique to handle effectively. So there are many key characteristics used in the hybrid deep learning, that is a combination of different models or techniques. So in this we have to use the different combinations, combining various types of neural networks like convolutional neural network, recurrent neural network, or autoencoders. So with these to exploit their complementary strengths. And next one is multi-model learning. So it is one of the key characteristics of hybrid deep learning. So this multimodal learning is used to where data from data sources are modalities. That means we have to take the data from the images or in the form of text or in the form of audio. These can be combined and processed simultaneously. A hybrid approach can be designed to take advantage of the strengths of different models, like the CNNs for image classification and transformers for text purpose. Next key characteristics is incorporating different training methods. So these methods are incorporating with both supervised and unsupervised learning methods. In this, the pre-training models can be fine-tuned on labeled data to improve accuracy and reduce the need for large labeled database. Next characteristics is improved generalization and performance. So this model is uses for the better generalization, but it is provides better generalization to new or unseen data by incorporating diverse approaches that help to avoiding overfitting to specific data sets. Next, challenges of hybrid deep learning. Complexity, data requirements, interpretability. Complexity means designing the training hybrid deep learning model can be more complex and computational intensive due to the integration of multiple models and techniques. So in the complexity, we have to the design and train the hybrid learning models. It is very difficult. Why? Because it is integrating different multiple models and techniques. That's why it is. That's why we have to model this such type of hybrid deep learning is very complex. And data requirements. So these data requirements uses different types of computational resources for training, especially combining different types of learning paradigms or large models. So here it is uses more data is needed to do the training and combining different types of models, or we have to take the apply the large data models. So data is very important and it is uses large amount of data. Next, interpretability. So this interpretability uses combining various architectures intricate with the decision making process. So this is also important in the deep learning models. Why? Because it is train and interpret the data as a very difficult. Next, security issues. So these security issues are for the GANs. So data privacy and data leakage. Data privacy and data leakage means for any type of data, Model inversion attacks, adversarial attacks on GANs, training data poisoning, model theft and intellectual property, that means IP protection, resource exhaustion and denial of service attacks, collaborative risks in hybrid models. These are the security issues in GAN. So from this denial of service attacks, so these attacks are also called as DOS, DOS or DDoS, distributed denial of service. So these attacks are mainly applies for the security issues of GAN. So first one is the data privacy and data leakage. So in this, the GANs are require a large amount of data to train the train the models in IoT environments. This data includes sensitive information such as user behavior, health data, location information, and device logs. So this is in the data privacy and data leakage. Example, in a healthcare IoT, GAN generated database on real patient data could leak personal health information. It is leaks the patient information. Next one is model inversion attacks. In the model inversion attacks, the hybrid deep learning model is combining GANs, and the advisory could attempt to reverse engineer or invert the trained model to extract sensitive data used for training. So in this, sensitive data is used for training and extract the data in a reverse engineering manner. Next to adversarial attacks on GANs. So in this, the GANs are vulnerable to adversarial attacks where slight modifications to input data can significantly alter the output. So we have to give the information in the input that can be slightly modified into the output. Next to training data poisoning. So in this, the GANs are rely heavily on high quality data for training. If the data used to train the GAN model is comprised or poisoned, the generated results may be inaccurate or malicious. So in training data poisoning, the output will be poisoned. The results will be in inaccurate format. Next one is model theft and intellectual property protection. So in the GAN, models can be valuable intellectual property, especially when they are used for advanced tasks like data generation, anomaly detection, or predictive maintenance. Next one, is the denial of service attacks. The GAN-based models, especially hybrid models, can be resource insensitive, requiring significant computational power and memory. Last one is the collaboration risks in hybrid models. So in this collaboration risks and hybrid models, the hybrid deep learning models are often involved in collaboration between different models or systems which can increase the attack surface. Next one about IoT. IoT means Internet of Things. So these Internet of Things used for the networking of physical objects that can electronics embedded within their architecture in order to communicate the sense interactions among each other with respect to the external environment. So the IoT is based IoT based technology present we are using for mainly as a differently for computing devices, mechanical and digital machines, objects, animals, people are provided with unique identifiers. This can be ability to transfer the data over network requiring human to human or human to computer interaction. Next, history of IoT. So this Internet of Things can be invented from 1982 to 2015. So there are vending machines, toasters, IoT coined, LG smart fridge, LG smart watch, smart iPhone, car testing, smart TV, Google Lens, Echo, Tesla autopilot. So these are the different variations or different previous history of the IoT. Next to modern applications. So with the help of IoT, we have to use different technologies like smart grids and energy saving, smart cities, smart homes or home automation, healthcare, earthquake detection, radiation detection or hazardous gas detection, smartphone detection, water flow monitoring, traffic monitoring, smart door lock protection system, robots and drones, security, healthcare and hospitals, telemedicine applications, biochip transponders, agriculture, hot monitoring implants, industry. So these are the modern applications. These modern applications are used in the IoT, Internet of Things. With the help of Internet of Things, we have to uh, apply the different types of techniques in these areas. Next. Thank you. Any queries? Thank you, Rajeshwari Garu. Thank you, sir. Thank you. So lastly, I am very thankful for Pencil Bridge for providing such a great opportunity to. Thank you for the management.
Hello, madam.
Sir, tell me, sir.
Good evening, good evening, madam.
Good evening, sir.
This is Dr. Prasad Dharnasi,
Okay, sir.
working as a associate professor in a CSC department from Holy Mary Institute of Technology and Science in Hyderabad.
Right, sir.
So I have one doubt. I want to ask with you. So please clarify it regarding our presentation.
Yes, sir. Sure, sir.
Uh, Conventional neural network techniques, where do you use exactly?
For image classification, sir, mainly.
Oh, classification. Where do you use?
Yes.
Please be explained briefly. I will be. Actually, I have a doubt, so that's why I'm asking you.
Okay, sir. Convolutional neural network means, first of all, whatever the image we have to take, that is divided into different
Okay.
convolutional layers.
Okay, madam.
So
And
after that, sir.
madam, tell me, madam.
So after converting different convolutional layers, the image is divided into different clusters. So for that, we have to apply the activation function. So finally, we'll get the result. So those activation functions already it said, sir, sigmoid function, tanh function, ReLU function, softmax function.
Okay, madam.
Thank you, sir.
Okay.
Thank you, sir. Thank you. Any queries, please? Sir, hybrid network means we are using different types of multiple networks. So that is different from the ensemble learning, sir. In unsupervised learning, we have to, yes, linear regression. Yes, sir, we are applying linear regression, sir. Rajeshwari, ma'am. So I am giving the difference between supervised learning and unsupervised learning, ma'am. So in that unsupervised learning, the data can be divided into clustering format. That means it is in the form of unlabeled data. That's why I am giving information about the clustering, ma'am.
Ma'am? Ma'am, it is audible, ma'am? Ma'am, thank you for your wonderful session, ma'am. It was a very great session. Thank you so much. Tomorrow session will be 10 a.m. to 12 p.m. with the same link. Thank you.
Thank you, ma'am. It's my pleasure, ma'am.
Thank you so much, ma'am.
Thank you, ma'am.
We can leave the session, ma'am. Thank you, ma'am.
Thank you, ma'am.